If you have SolidWorks Office Premium, then you can take advantage of the Tolerance Analyst to perform a stack-up analysis of the components in your assemblies. To enable Tolerance Analyst, you can turn it on from the Tools, Add-ins drop-down menu. When I select it, the Tolerance Analysis Study icon becomes available from the DIM Expert Manager tab. Before launching a study, you should know that the Tolerance Analyst utilizes information from the DIM Expert in each component. If I tile my windows, you can see that each of the parts in this assembly already have information from the DIM Expert, each with their own tolerances. That said, let's get started. I'll click on the Tolerance Analysis Study icon to begin. In the first window of this wizard-style interface, we'll tell SolidWorks what is the critical dimension that we want to perform the stack-up analysis on. In this assembly, I'd like to find out what the stack-up could be for the overall height of this assembly. When I select them, SolidWorks tells me what the nominal dimension between them is, and I can locate the dimension on my screen. To proceed with the wizard, I'll be using the Next arrow in the Property Manager. Next, we'll tell SolidWorks which components to analyze, and to select them in the order that they would be assembled. I'll select the base plate first, then the center bracket, and the riser on top. With the components defined in the proper sequence, I'll click Next. Here in this step, we just need to tell SolidWorks which mates are connecting each of the components in our study. This simulates how the components will be attached when manufactured. You can see the base plate is already defined since it's the first component. I'll click on the bracket component in the center, and I can select the mate that attaches the bracket to the base plate. Notice these flags have the numbers 1, 2, and 3. These numbers allow me to specify primary, secondary, or tertiary mates for analysis. One thing to be careful of here is to again choose the mates in the same order they would be affixing in manufacturing, since choosing these in a different order could lead to different results. I'll select the coincident mate as the primary mate between these two. When I select it, a green check is placed next to the center component. For the top riser component, I'll again use a coincident mate for the connecting faces, meaning I've provided at least the minimum information SolidWorks needs to perform the stack-up analysis. When I click Next, SolidWorks gives us the results of the study. We can see the nominal distance, as well as the minimum and maximum values. SolidWorks also gives us an Rss Min and Max, which stands for root sum squares. While min and max values give you a worst-case scenario of the stack-up, Rss Min and Max uses a statistical formula to give you values that are more likely to result. In the graphics area, we can see a flag pointing to where the worst-case max value would be, along with the preview. This preview can be really helpful when you have components close by, in order to determine if you should have more clearance in your design to account for this stack-up. I'll click the Min Radio button in the Property Manager, and again see the flag with the preview.